Thank you very much, Daniel, and a good afternoon or good evening for all of you that are attending this session. It is a great pleasure to introduce our lecturer tonight, Michael Corns. He is coming from the UK. He's a consultant clinical scientist at Worcestershire Acute Hospitals and NHS Trust. And I have the luck of knowing Mike for the last two couples of years, for 3, 4, 5 years, since we both are in the EFLM pre-analytical working group. Mike is also the chair of the UK pre-analytics working group, and he has been publishing a lot in this area. It is one of his interest areas. All this that is related to the pre-analytical subjects. And this evening he will be guiding us through a subject that is sometimes a point of certain dispute and certain conflict, and the subject is the order of draw. And he entitles his own presentation as the order of draw, myth or science. So, Mike, the floor is yours. Please start your own presentation. Thank you very much.
Okay, thank you, Tiago. Thank you, Daniel. Good morning, afternoon, evening from wherever you are. As you can see, hopefully you can see me okay. We have actually, as you can see behind me, actually got sunshine in the UK. This will probably be our summer finished after today. What I'm going to do today is talk you through the area of order of draw. I am an advocate of order of draw, but what I'm going to try and do today is talk you through the controversy about whether people support or don't support it, and what the science is behind both not following order of draw and following order of draw, and hopefully convince you that following order of draw is the right thing to do, or at the very least give you the balanced arguments for you to make your own decision. So let's start with a little bit about where I am. So Worcester, as you can see, is kind of right in the middle of the UK. It is a city, but it's quite a small city. Just to give you a bit of perspective, it's kind of about 70 miles north west of London, or about 30 miles south of Birmingham, for those that know the big cities. And it's based over 2 sites, which I'll give you pictures there. But so pre-analytics, there's been those that have listened to speakers from either myself or other colleagues in the European group will have probably seen this sort of slide before. But the pre-analytical phase is one of the areas where we see the most errors generated within the total testing pathway. We've got the analytical bit really nailed down now, and really sorted, so we don't get very few errors there. But the pre-analytical phase and the pre-analytical phase are still areas where we can really work. So in the analytical phase, we have mechanisms to pick up these errors, and these are what we're developing now in the pre-analytical phase and the pre-analytical phase, along with standards to improve them, and obviously the post-analytical phase as well, but we're not going to cover that at the moment. So order of draw, where in the process does the importance of that happen? So the main part of it is so order of draw obviously happens at the point of collection. That's where you can do the right order of draw or the wrong order of draw. Now, if you do the wrong order of draw, the potential impact is then on the analysis, in that we generate erroneous results from the blood tests. This can then have a knock-on effect, because often, although there's an error happened, we don't have a way of knowing that it's an error unless it's quite glaring, or there's been a big change in results, or something we can pick up on. So it's important to stop the error happening in the first place, and obviously this will go on to affect the way it's reported and ultimately the patient's pathway through your healthcare system. So these are just an overview of what problems you get associated with order of draw. There's hyponatremia if you get sodium citrate contamination, be it from a blood tube or from a citraloc solution, best known. Problem with order of draw, you get high potassiums but low calciums, magnesium, zincs, irons, phos. You can also get effects on coagulation due to transfer of anticoagulants. And obviously, if you are if you're transferring liquid additives, then there is a small dilution effect to consider as well. So what I'm going to do is just start with a couple of cases, then I'll go through the facts for not following an order of draw, followed by the data behind why you should follow an order of draw, and then a few possible mechanisms you can use to try and mitigate this in the laboratory. So this is a genuine case, and we'll actually see the paper that was published in later on in the talk. But we had a sample that came in from the general practitioner, which had an indirect sodium measured at 170 millimoles per litre. Potassium was lowish. Urea, creatinine, glucose, fairly unremarkable. The patient then came into A&E, to the emergency department later that evening. The sodium was repeated, came out 137. Other bloods, either similar or perfectly normal. Potassium had obviously gone up slightly. We did some additional testing on the sample, so we then ran direct ISE and got a sodium result of 145, which obviously is different to the indirect. As I'll explain later, this difference is one we're struggling to explain, but as we'll see later a bit more about that. We also measured the chloride, and this is where it began to indicate there was a problem, and that the chloride was very low, which is out of kilter with the sodium, and the osmo was also low versus what you'd expect it to be by a calculated osmolality. So in the repeated bloods, you can see that the sodium agreed, the chloride agreed, and the osmolality agreed. So we're happy that the second set of bloods were genuine, and there's something wrong with the first set of bloods. We actually contacted the patient regarding this sample, and the patient said they did remember the phlebotomist pouring a tube from one into the other. So, and this kind of is one example of what can happen, but when you're pouring, it's fairly easy to pick up. So what explains this? This is sodium citrate contamination. The second case, probably a more common case, normal sodium, high potassium, urea and creatinine fairly reasonably normal, indicate it's not a renal potassium. It gives you a little flag that maybe this potassium isn't all it seems to be. We then added on a calcium, an alk-phos, and an albumin. You can see the alk-phos was lowish, but it's not a good surrogate, as we'll see later. But the calcium was low, which is a better surrogate marker for EDTA contamination. You can see that this then was suspected EDTA contamination. So a bit of the history of order of draw. The order of draw was established based on a paper in 1982 by Calam and Cooper, where they discussed the problems of EDTA contamination. And they said that when a blood sample tube contains an additive, there should be an order to taking it so that the carryover is not done. And you need to adhere to a correct order of draw. So that's where the term first arose. And it's still this paper from 1982 that is referenced in the CLSI guidelines. They did, however, if you read the paper, later go on to say that reversing the order of draw had no apparent contamination effect on the results for SST tubes, which suggests that the contamination most likely only occurs when there is difficult phlebotomy. So I think you can see here that even at this early stage, there was a bit of controversy, even within the original paper that the CLSI guidelines rely on. So these are this is the order of draw as recommended by the CLSI guidelines. And there are various little tools you can obtain to help you remember the order of draw. And I've just got a picture of these. It can be a little clip card you pick on. You can actually clip the tubes onto your sleeve in the right order to make sure you take them in the right order. You can wear bracelets. I'm always a bit dubious of these ones because presumably it depends on which point on the bracelet you start from. Pens, another sort of bracelet, which has the same problems as before. So is the order of draw a myth? Well, this was an article that Reuters did, and they asked me to put together a little comment on it, which I did, and then I went on later to see what people had commented on the article. And I got a comment that Dr. Corns notes that their evidence support is virtually non-existent, but still recommends the process occurs. Another outdated practice that's very hard to shift. But then you get some more positive ones where people say if you take a EDTA tube, calciums and high potassiums. Again, someone else saying that they do see this. Another one saying we do see this. Another comment which I think is quite good in that it is an established best practice and should remain so, if only not to confuse people. And I'll come on to my opinions on that later, but I stand by that comment. I agree with it. And again, this is another good point. Order of draw, as I hope I will show you, does still occur. Problems with order of draw, and it is still a problem. And it's not like it's not a hard intervention. It's not a costly intervention. It's not complicated. It's very simple. It's very easy to do. There's no detrimental effect. So there is really no reason not to do it. But you can draw your own conclusions. So what I'll do now is go through a few papers that have looked at the fact that there is no impact of order of draw. First of this is a study that looked at two different sets of patients, healthy and those taking warfarin, and they took a tube before and after a serum tube, and to see if there was an anticoagulant carryover. And basically, the data shows that there was no carryover anticoagulant, and when standard phlebotomy practices were followed. So they made the conclusion that a coagulation tube after serum may be acceptable when standard phlebotomy procedures are used. And I think that's an important phrase we'll see quite a lot, when standard phlebotomy procedures are used. And they do say that further big studies are needed. This is another study which did a very, very similar thing. They did a before and after a heparin tube, and before and after an EDTA and a serum tube to see what effect that had on clotting. And again, they showed that there was no real significant difference when standard phlebotomy practices are followed correctly. And of interest, this is actually the paper that triggered the Reuters article. This is the one they picked up on. So there's a few other papers that are around. So the order of draw of blood specimens into additive-containing tubes does not affect potassium and calcium measurements, and they looked at the average difference between potassiums taken in the control and taken in the trial, and showed that actually they showed a big difference in potassiums, albeit very, very small in both cases in the control group. Just going to show that there was no significant difference at all pre and post. And the statistics showed that, just illustrating that there was no significant difference. So again, they conclude that order of draw does not affect potassium and calcium measurements. This is a paper, and we'll see again, there's a few papers from me in this, and there's a few papers from Giuseppe Lippi and his colleagues. And this one, what they did is they did a series of analytes, potassium, sodium, calcium, magnesium, and phosphate before and after an EDTA tube, and before and after a sodium citrate tube. For all these analytes, regardless of whether it was taken before or after the particular tube of interest, there was no significant difference in the results before and after. So studies we've done. So what we actually did is, and what triggered my interest in kind of in pre-analytics to begin with, is back when I was training for my project as training, I set up an assay to measure EDTA based on a paper by I think it was Fraser Davidson and his colleagues up in Scotland, and we ran it on a Roche analyzer. But what we did in this case is we did a sample taken, as Giuseppe Lippi did, sample before and after an EDTA tube. We did it in a sitting and a lying position following the manufacturer's guidelines for phlebotomy, and we actually measured EDTA in these. So what we showed here is, in agreement with the papers, when phlebotomy goes well, there's no difference between the sample taken before and the sample taken after EDTA, and you can also see that there is no EDTA detected. That was done in Sarstedt tubes. We repeated the study, exactly the same study, in Becton Dickinson tubes, but without doing the sitting and lying, just did it in a seated position, and again showed that there was no difference. So again, we're showing that incorrect order of draw, and again I'm emphasising under ideal phlebotomy conditions, does not cause contamination, irrespective of the closed blood collection system used. So in all those scenarios that we've discussed in the evidence showing that phlebotomy order of draw has no effect, in all those they were all experimental conditions where phlebotomy was done under ideal conditions. obviously in the real world, this isn't always the case. So the studies that follow now are actually looking at real laboratory data to see what's really happening and what we're really seeing. So this first paper, again, this is Giuseppe Lippi and his team, and they looked at contamination by 5 up to, it's quite small, I'm afraid, I think up to about 50% contamination with EDTA, and they showed that EDTA starts to affect analytes with only 5%, especially things like calcium, magnesium, potassium, chloride, surprisingly, and LDH. And at slightly higher levels, iron, phosphate, and sodium start to get affected. Presumably at that levels, you're starting to get dilution effects coming in. And I think interestingly, the next paper did a very, very similar experiment, but slightly more scientifically in many ways, in that they, in this case, they measured EDTA by mass spectrometry. But they also then added amount of EDTA in terms of a volume rather than percentage. So they added 1 microliter, 5 microliters, 10 microliters, and 100 microliters up to 1,000. And what this shows is that a value of about 10 microliters, you get the potassium effect, you get the effect on magnesium, and you get the effect on calcium. And that's at the kind of 510 microliter volume, which coincidentally is about the same size as a droplet of blood, or a droplet of liquid, sorry, only liquid. I think 10 microliters is a droplet of water. Blood being a bit more viscous is probably slightly larger. But what this goes to show is it only takes a single droplet of carryover if you manage to carry over a pure additive from a liquid additive tube, then 1 droplet is enough to cause contamination. And I'll explain why this is important later on when we look at possible mechanisms of how it could occur. So this is the sodium citrate contamination paper that the case earlier was from. So what we did after the original case to prove that this was a tipping across error, and because of the fact that we got this difference between the indirect and direct sodiums. So on this, the AVL is our direct analyzer sodium. So we ran 3 volunteers from the laboratory. I think it was me, my boss, and my other boss. And we took our blood. We then poured some of it into. We took it into an ESR or coagulation tube, poured it into a serum tube, and measured the results. And again, what we saw was that the sodium for the direct was very different to the indirect, which again, this is one we're struggling to identify. The chloride did not agree with the sodium when there was sodium citrate there, as you'd expect, because it's not sodium and chloride, it's sodium citrate that's actually present. The osmolar gap also had a much bigger gap in these scenarios, which again is not would be explained by the fact that when you've got sodium and chloride, it's a 1-to-1 relationship, whereas sodium and citrate, I think I'm right in saying, is a 1-to-3 complex. So you will get a difference in the osmotic activity of the things in there. So we showed that the pattern was repeatable, and that was quite common. And we actually, since we've identified this and know to look out for it and put pathways in place, we actually pick this up as being much more common than you might think. So another evidence behind EDTA is this is a Tunisian study, and they looked at how frequently EDTA contamination was occurring in their population. Obviously, this is a slightly more developing area of the world. And they showed that before an educational or awareness campaign, they were actually getting 44% of their high potassiums were due to hyperkalaemia, which I think is phenomenally high. And even after the educational awareness campaign, they're still getting 27% of the hyperkalemias were due to EDTA contamination. But I think, as you can see in the data, the total cases of hyperkalemia did reduce significantly. And they were using quite a low cutoff of 5.8 to identify hyperkalemia. So I think you can see it's made quite a difference with them. But it does go to flag that if you take in the globe into perspective, that EDTA contamination is quite a significant problem still. Again, this is back to Giuseppe Lippi now on the again on the side of the fence in terms of showing it does happen. And this actually is a point of care scenario, which I think is really important to consider, because it's, although we set up point of care to be performed to the same standards as the laboratory, obviously in most scenarios the laboratory isn't present at the point of care, so we're not necessarily there to look at the results, to interpret these results and say, hang on a minute, that doesn't look right. I wouldn't recommend you take any action on that. I think I would check it. In this case, they got a high potassium in a syringe put through the blood gas machine, and a very low calcium. And luckily, somebody noticed it, contacted the lab, said, what could this be? They obviously said, I would suggest you repeat it. Did you take any other tubes at the same time? In this scenario, it turned out they hadn't quite taken enough. They forgot they needed blood gas, so they had to tip some blood across. And obviously this situation arose, which again, had they treated based on that potassium, would have had a very big impact on the patient pathway. Back to some of the studies that I did the first time out in this is we started to look at all the hyperkalemics we got in the laboratory, and we found that 28 of our 117 samples were contaminated with EDTA. We also looked, so this initial paper was looking at the other surrogate markers that can be used, and we found that only zinc values below a reference range had a 100% sensitivity for EDTA contamination. However, although it was sensitive for this, it wasn't very specific. So there were some genuine hyperkalemic samples that, if you purely use zinc, we would have rejected them as contaminated, whereas in fact they were actually genuine, which would have delayed the inpatient because we had to wait for a repeat to be done to confirm it's the fact that it was genuine. In the follow-up study, a colleague of mine led, we didn't just look at hyperkalemic samples, we looked at the other surrogate markers and used them, and if we identified samples that had a calcium less than 2 or zinc less than 11 or magnesium 0.7 or high potassium, we looked at, of the EDTA contaminated samples, of which there were 31. Of these 31, 9 were found by routine screening and 22 were found as a result of this audit. So that's 22 contaminated samples that were missed in the laboratory. And obviously you can see the percentage that would have been picked up by each criteria. So you can see that none of the criteria are 100%, apart from the fact that if you actually measure EDTA, but that's only 100% if you direct all samples that hit these criteria to be analysed for EDTA. But in the case of routine screening and the audit, it was zinc that was the best surrogate marker, followed by calcium and magnesium. High potassium itself isn't actually a great marker in isolation, because, I mean, as you're all aware, if you get a low potassium and a little bit of EDTA contamination, it might just push it into the normal range, or it might just move from low normal to high normal. But either way, it's not going to flag up to come to any authorization list, nor would it really raise alarm bells if it did. So following from this, we then also started to think, we've done a few experiments in our own laboratory. What if it's just us? What if we just have a particular problem where we are with EDTA contamination? So what we did is we contacted 6 labs. We only managed to get data for 5. So we actually wanted to get 2 Sarsted, 2 Greiner, and 2 Becton Dickinson labs. And they sent us all their hyperkalemic samples for a period. And we ran them for EDTA contamination. And then we looked at how many were identified by the lab and how many weren't. So you can see for the 2 Sarsted labs, they're actually both the labs that do run an EDTA assay. So they were all identified via a process. But what this does show is that Sarsted does seem to have a higher preponderance to get EDTA contamination. And I'll discuss reasons why we think that might be. It's a hypothesis, there's no proof. It's just an idea. And Greiner and BD seem to have slightly lower numbers. But I think the key thing to look at here is the fact that for all of these that are not got an automated mechanism, you're missing around 50% of EDTA contaminated samples. So what we're saying here is that gross contamination, if you get a potassium of 9 or 10, it's really easy to identify. What's difficult is those that potassiums of 6.6 or even those that are normal range or have subtle contamination, which are enough to throw the results off, but not enough to necessarily flag it to us as a glaring erroneous result that needs to be examined. So I said it earlier, I'd talk about the possible mechanisms. So in our minds, there are three possible mechanisms of how EDTA contamination can occur. There's direct transfer, as I've just said, where you get big changes in results, big results that are not compatible with life, or certainly not in keeping with the clinical symptoms of the patient. So they're fairly easily identified, and we do hopefully all pick them up now. Then there's a hypothesis of backflow due to incorrect order of draw. So if you take the incorrect order of draw, as you're taking the samples, does some of the additive get sucked into the vein and then transferred, or the needle device, and get transferred back into the blood tube if you're doing the wrong order. So if you take an EDTA sample before a serum gel, is some of the EDTA managed to transfer that way? Or is, as we think our best hypothesis is it due to syringe needle contamination? So this is what I mean is when you're doing your phlebotomy, but you don't follow manufacturer guidelines, which I think quite often happens, as we'll see in a minute, in some areas and with difficult phlebotomy, because people find it easier to use a syringe and needle in some circumstances. You then get a syringe full of blood, and it's how you transfer that blood from the syringe into the tube that could be important. And I'll discuss, we'll see the various ways they could do it over the next few slides. So it's actually big it makes big news in the UK, the fact that this was an article that picked up on a paper showing that, that we'll see in a second, that practices of phlebotomy in a lot of A&Es isn't that great. But I think a lot of emergency departments in the UK are starting to move to having dedicated phlebotomy teams in the emergency department who take blood day in, day out, and are really good at it and follow manufactured devices, because there are papers, not coming here, that have shown that if you get phlebotomists taking it, you save enough money from avoided errors to self-fund, make it cost neutral. So is it due to syringe transfer? So this is a study where another fellow professional went down to the ED department and just sat there observing how they take blood in the emergency department. And what they showed that was in only 42% of the time did they do it the right way, i.e. following the 6% of the time they did evacuate tubes conventionally used. 42% is with a cannula with an adapter and tubes. But then in 52% of samples, so over either directly into a vein or via a cannula. And all of these, so then looked at how was the sample transferred from that syringe into the tubes, and basically look at whether it was it via a needle pierced into the tube, as you probably would, got to simulate taking it from the vein, kind of, or did they take the cap off and then squirt the blood into the tube? Now, if all of these can potentially lead to contamination. I think if they're going through the tube cap, it probably limits it slightly in that they are not going directly into the tube, and it will kind of self-wipe off as it comes out, so you won't carry droplets with you. But I think, firstly, if you're squeezing it into a tube, you've got the increased risk of hemolysis, regardless of order of draw, so it's not great practice. If you have the lid off and you scrape it against the side of the tube, then whatever the additive, you could be picking up the powder that you get in Griner or BD tubes, or a droplet that you get in Sarstedt tubes. But either way, there's a chance of picking up a droplet, which comes back to my earlier comments about droplet size. A single droplet is enough to affect results. So if you're doing it this way, you do it in the wrong order and you transfer a droplet, that's enough to cause contamination. The other thing I think to note here is blank now. I'll come back to it if I remember. So the other thing they looked at is, did they actually follow an order of draw? And you can see here that 41% of the time they took the potassium tube first, followed by the other tubes. And so 41% of the time they are following incorrect order of draw in the emergency department. And more worryingly so, in 4% of cases, they did do the serum tube first, but then they did the EDTA tube, realised had a bit of blood less, and went left and went back again. And I think this practice of going back and two is really quite concerning. So what should we do in the laboratory to try and mitigate this? Well, obviously, ideally, in that ideal world, we develop an assay to detect EDTA. But even if you have that, given that the laboratories are under increasing pressure to get a turnaround time up and increasing competition for reagent space, shortage of staff and that, it's difficult to work out. You've basically got to develop an algorithm of which samples go for EDTA contamination. You know, in the perfect world, you'd have it as a fourth indices, and every sample would be tested for it. But then I think you could open up a whole argument about what else should be in indices. You could put in, I mean, over the years, new tests will be established to check for poor sample quality. And, you know, if we start running 10 indices before we do any tests, we're going to significantly delay our turnaround time. So I think it's got to be done with a bit of pragmatism. The other thing you can do is, if you don't have an EDTA assay, is develop algorithms that look for surrogate markers, for example, of EDTA, or running chlorides for sodium citrate, to try and pick it up that way. And we'll see a couple of examples in the next few slides. That slide just illustrates the sensitivity and specificity of the surrogate markers that are available. You see that zinc is the best, but it's not very specific. So this is again a paper that a former colleague of mine wrote, kind of at the similar time as I was doing the EDTA work. She was looking at algorithms of how you investigate hyperkalaemia and hypernatremia. So for hyperkalaemia, you know, you kind of go down the, is it expected result? No, consider pseudo-hyperkalaemia. Is the hemolysis present? If not, then you start to go down the EDTA route. Look at adjusted calcium. If it's low, then you start looking at the other surrogate markers to try and confirm that it's EDTA contamination and repeat the request. If it's normal, then you start to go down the route of leaky cells or high white cell counts, things like that, other causes for erroneous hyperkalemia. The other thing, however, going down looking at surrogate markers and without a dedicated EDTA assay, is you sometimes get a grey area where it's not very clear cut, and we then put a comment on to say, suggestive of EDTA contamination, please interpret with caution and consider a repeat. So for sodium citrate contamination, for sodium hypernatremias, again, you go down the osmolality, rule out genuine causes, look at pseudo-hypernatremia. Then the key then is to look at the chloride. If the chloride is appropriate, then it could be a hypoproteinemia, and you could do a direct ISE to check that. If it's inappropriate low, then you're thinking sodium citrate contamination, you request a repeat. So just a few conclusions, and then I'll try and answer any questions. There are many opinions in order of draw, and we've had debates within our own pre-analytical working group about whether it should or shouldn't be followed. My opinion is that there is no disadvantage of following order of draw. The science and the evidence out there clearly shows that it is still a problem. Given that there is no disadvantage to following order of draw, and there is a problem, why wouldn't you follow it? I can't come across a good reason why not to. However, you know, we have proven that if you do follow the manufacturer's guidelines and take the bloods properly using a closed loop system as they recommend, then you can take the samples in any order because contamination won't occur.
Thank you very much, Mike.
The other thing that we don't know from this is, yes?
Yes, please.
So the other thing that we don't know from this is how the contamination occurs. So ideally we could do with just investigating that, but because we don't, it's very hard to get ethics to start performing phlebotomy badly to investigate how it might occur. So nobody yet has done this. I think that's where I'm going to finish. I just want to make one last plug, really, in that over the last few days, over the last few years, the European group has been developing its own phlebotomy guideline. So an EFLM phlebotomy guideline, which has just been sent to national society governing bodies for a final vote. Or hopefully it's published for use across Europe. So I'd recommend you keep an eye out for that. It's quite a pragmatic document, and it does also recommend the order of draw is followed. It's well worth looking out for, and will be well publicised when it's released. With that, I'm happy to take any questions. thanks for listening.
Okay, thank you, Mike. The one of the problems, and you know it very well, is that when some of the errors, some of the mistakes are occurring in a low frequency, people tend not to consider them as very important. And how do you consider the everyday burden of this kind of errors, or the probability of occurring one of these order of draw errors? What's your appreciation of this?
I think, in my opinion, the trouble with order of draw is because we don't have great detection mechanisms for it. When the studies that I've been involved in, the studies I've seen, is they all tend to show, when you look into it, that the occurrence of it is actually quite a lot higher than we think it is. And obviously, it's a small proportion of the 3,000 samples that comes to the lab, but it's quite a high proportion of the hyperkalemic samples you see are due to some small contamination. And I think, given that order of draw is so easy, there is no reason not to do it. That although the significance relative to the 3,000 samples is small, there's no reason not to follow the order of draw, because these occurrences can be very simply, very cheaply avoided entirely. And although you may say the significance in 3,000 or whatever samples is small, to those 30 patients that are a month that have to come into the emergency department to have the bloods rechecked, I think they would argue that is quite significant to them.
Yes, that's an important point, because if you consider all the workout that you have when you have an hypocalcaemia, for example, that is not expected or has no relation to the expected according to the clinical condition. When you consider all the workout of samples just because of one of these small drops, it really is. It may turn into a big burden. Yes, this is really important. And economically, and in terms of workload, what's your opinion? It really is. It really may be important.
So I think in terms of economically, there's two ways of looking at it. I think it is important, and I think we found that I think I made the point that the EDTA assay itself is very, very cheap. It's a home brew method. It's published, you can make it, but the actual assay itself it costs pence, if that, for each analysis, and it's very, very quick, so it doesn't delay things very much. And I think if you take the cost of that versus the cost of a patient coming into the emergency department to be rebled, a few pence to make sure the result's valid, is a much more economical way of doing it, given that the laboratory is the best place to deal with it.
Yes. Also, something that I've been thinking during your presentation is that when we consider in terms of patient safety, and we know this is one of the biggest issues nowadays, and it is one of the areas where where laboratory medicine can make a difference in terms of the final outcome for the patient. Do you think that when we may look to the order of draw as a kind of safety checklist in terms of reducing the probability of having problems, of having any kind of problems in terms of cross-contamination?
I think exactly. I think the way to look at it is the order of draw is it's an entirely free way of completely eliminating a laboratory problem. There is no cost involved in this other than training, but as it's already embedded in all the training procedures, there is no cost, and if everyone follows it, there will be no erroneous results due to incorrect order of draw. So I really see no downside to following order of draw.
If I may add it's sometimes the biggest problems come in the simple and clearly accepted by all acts, because it is simple. to accept an order of draw. Everybody considers this is a kind of low-tech activity, but in the end, it can add lots in terms of patient safety and in terms of waste inside the lab. Because as you were telling earlier, if you have thousands of tubes, if you have hundreds of draws, this is not really something as rare as people sometimes consider. Yes, we have been asking for our participants to have some questions arriving through the chat. I don't know if people are knowing it or using the chat as a way of asking Mike for his opinion on some of these aspects related to the order of draw subject. In terms of training, I also think, and I would like to have your opinion on that. When you are training people, it is very important that you train them and you give them some kind of guidance. When you are training someone, is it much more difficult if you are not giving guidance? What's your opinion on this?
I think when you're training, and I think that we'll see this with the new FLM training package that comes out with the guidelines, is that what people want in the sort of litigious society that we seem to be developing, where part of the concern is avoiding lawyers and mistakes and getting prosecuted, that if we provide guidelines at this that say clearly this is how you should do phlebotomy each step of the way, including order of draw, in which case this is how you take the tubes, then if you do that and you can confidently say that you always follow that, then there is no risk that you have done anything to affect the patient that could come back in a negative manner. I mean, not that I think it would in order of draw, but I think what people want is clear guidelines that have no grey areas where they can do their own thing. They want to know what they're doing, how they're doing it, when they're doing it.
Yes. One other question that came is asking for your recommendation or your opinion when you have a difficult phlebotomy, a difficult patient, and you will really need a syringe. What is your recommendation, especially if you need, for example, a calcium determination, a calcium analysis? What should we do?
I think this is a good question in two ways. I think that the fact that you asked this, it shows that it highlights the fact that using the ideal phlebotomy manufacturer's pathway isn't always possible. And that's why we need to stick with an order of draw, because in this scenario, you take the syringe of blood, then if you know what tubes you need to fill with the blood. The important thing is to make sure you still fill the tubes in the correct order of draw. And if you underfill one of the first ones, it's important you don't go back to it. You're done with that one. So I think if you have a syringe with no additives, you follow the correct order of draw, then you shouldn't have any problems getting the analytes you want. Obviously, there is the proviso that you don't want to be squirting the blood out at a high rate to get hemolysis, which will affect a lot more than the calcium analysis. But I think it does highlight the fact that the needle, using a syringe and needle, will, for the foreseeable future, always have to occur on certain occasions, and that's where it's really important that you follow the right order of draw.
Yes, I completely agree with you. Even in that condition, try to follow the order of draw. What's your in these conditions, rare, but they still occur when you are using a syringe and you are opening tubes. Have you any kind of experience, or have you seen that when people mix the stopper, when people are recapping the tubes and they recap it in a wrong way, and then they change the caps to the previous order, to the correct order. We have seen sometimes that occurring, and it goes to the drops that you were talking earlier.
And I think, again, it's like you say, it's another mechanism of getting the drops across that we don't want. I mean, my advice would be that you never don't decap at all. You put the needle in through the top of the tube and put it in that way. Make sure you're using obviously the right gauge needle, and it's a gentle addition. But the only way to be 100% is not to decap at all. I think if you do decap, the risk of droplet transfer is just too great.
Okay, I think for a moment I was still waiting for more questions. Anything else, Mike, that you think it could be told about this aspect, and something that you have recalled in this during your presentation that you think it could be relevant?
No, I think the key take-home message is just that this is still occurs. The fix is already in place. It's free and it's easy, and we're already training on it. So a change away from it, it's all negative. The reasons to change, I see no positive in changing it.
Yes, I completely agree with you. We don't need any kind of CE mark or FDA approval. It's really, I totally agree with you. It's easy, it's cheaper. We already know how to do it, how it functions. Why transform something in a try to complicate something that is easygoing, and it's affordable and everybody everywhere. And this is very important. Very important. The more we are looking to global aspects, the more we are looking to global health, the more we are looking to global health diagnostics, it is important that this kind of easy, cheap, good practice aspects are well known and are in a certain way are known and disseminated all around. We have still another question. Should we use, and this is about the quality or kind of needles, if we should use special needles? This is a bit different, not, but still, what's your opinion for difficult, when you have difficult accesses, difficult extractions? Should we use different and special needles for this?
I think it's a little bit outside of my expertise, but I think, I mean, my advice would be that you stick with what the manufacturers recommend, and you make sure that the needles have the right gauge so as not to cause other pre-analytical problems. But obviously, I mean, these recommendations are always for the masses, and there are always going to be isolated patients that are a real difficulty, and you have to just do the best you can with that. But regardless of the needle used, the order of draw remains the same.
Yes, I agree with you that the end product is the order of draw, and stick to the order of draw. I think we are now empty of questions. I don't know if Daniel wants to say anything more. Thank you very much, Mike. Thank you, and I hope that your borrow is happy tonight playing the playoff again against Aston Villa. And see you soon. Bye bye. Thank you very much, and thank you all the attendees of this webinar, of this EFLM webinar. Bye bye, and a good evening for all of you. Thank you.
All right. Thank you. Thank you all.